All right, laws of exponents, day 2. So we're up to the third law, and here's what it says. When you divide numbers or variables with the same base, always the same base. All right, so when you divide numbers or variables with the same base, you're going to subtract the exponents. So here's what it looks like. If you have a to the x power over a to the y power, so a is the base, same base, then you're going to keep the base and do x minus y. And it's always the top number minus the bottom. Okay? All right, so let's look at why this happens. And I'll do an example here. Let's say 4 to the 5th over 4 to the 2nd. All right, so if I expanded this out, if I didn't know the laws, right? What does this mean? This means 4 times 4 times 4 times 4 times 4 all over 4 times 4. Now, when you do 4 divided by 4, you get a 1, right? So really, like, these can cancel out to be 1s. These can be canceled out to be 1s. Look what's left. 3 4s on the top, so that's really 4 to the 3rd is left. And look, 5 minus 2 is 3. So this is why it's happening. All right, and then we could solve it because it's a number. 4 to the 3rd, that's 16 times 4, 64. All right. That's actually way easier than figuring out 4 to the 5th and dividing it by 16, right? I think that's better. So this is actually useful. Now, if there's just variables like x to the 8th over x to the 3rd, again, if you wanted to see what was going on, x is up top, 3 on the bottom, same thing could happen. Boom, 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 and we've got 1, 2, 3, 4, 5 x's on top, and look, 8 minus 3, we could have jumped right to 5. So just like before, I don't need this in-between step. Once we know the law, we can just go with it, we can use it. All right, but I wanted to show you why it's working. All right, so let's try some here. All right, how about 10 to the 7th over 10 to the 4th? All right, so that would be 10 to the 3rd, which is a 1 with 3 zeros. Okay, try one with variables. How about x to the 25th over x to the 18th? All right, hopefully you got that's x to the 7th. Okay, now I'll get a little meaner. Remember, the laws of exponents are just for the exponents. All right, so let's try 12m to the 5th over 3m. So 12 divided by 3 is 4. M to the 5th over m to the 1st would be m to the 4th, right? 5 minus 1, 4. So again, you're dividing just the normal numbers here. The exponents is where you use the laws of exponents. I know that sounds silly to say, but you got to remember, these new laws are just for exponents. All right, try 20x to the 4th, y to the 3rd over 2x squared, y squared. All right, so 20 divided by 2 is 10. X to the 4th over x to the 2nd is x to the 2nd. And y to the 3rd over y to the 2nd is y to the 1st. You don't need to write the first, you can just leave it like that. A little meaner. What if it was 4x to the 2nd over 16x? This one I kind of treat like, 4 over 16, it's kind of like I'm reducing a fraction. That would be 1/4. So you could put the 1 up here. You don't have to put the 1. X to the second over x is x to the first up top. So your answer actually could look like this. X over 4. Okay, so sometimes, yeah, I kind of treat these like fractions. Maybe I'll do the next one like that too. So you've got 7x to the third y to the fourth over 21xy. So I kind of set it up like this. What's going on? This is going to reduce to a third. You got 3 x's up here, 1 on the bottom. Once you cross out, that's going to leave 2 up top. 4 up top, 1 on the bottom. That's going to leave 3 up top. So this is x squared y cubed all over 3. Okay. All right, good. And just before we move on to the fourth law, I just want to remind you, in case this happens, anything to the 0 power is 1. Remember, we talked about that. If you want to be reminded of why that works, we'll pause it and talk about it. But anything to the 0 power is 1. 3 to the 0 power is 1. X to the 0 power is 1. That's just something you have to memorize. Okay? All right, good. And then the fourth and last one, so we'll call this fourth. This is negative exponents. I'm just going to label it negative exponents. And I'll show you what they say here. So they say base is A. If you have something to the negative exponent, what happens is you flip it over into a fraction, and now it's a positive exponent. What? Yeah. Let me show you why. Okay, so let's say we had a problem 5 to the 4th over 5 to the 6th. If I expanded this out, that would be 4 5s up top and 6 on the bottom. Okay, so let's start canceling like we did before. These are 1s now. 1s, 1s, aha. This would be 1 over 5 times 5. So that's really 1 over 5 to the second, right? Which you could solve. But let's just focus on this. 1 over 5 to the second. If we use the law we just learned, wouldn't we have done 4 minus 6 and gotten 5 to the negative 2? So that means that has to equal 5 to the negative 2 is the same as 1 over 5 to the positive 2. All right, so here's where you learn how to solve negative exponents, because I always get that question. Are we ever going to learn negative exponents? Yeah, here it is. 5 to the negative 2 is 1 over 5 to the second. You get a decimal, 1/25. So you don't get a negative number. That's kind of interesting. You get this fraction. It flips it over. All right, so let's try some. Okay. So the directions would probably say, leave your answer with positive exponents. That's what it's going to say. All right, so if you have an example like b to the 3rd over b to the 9th. So 3 minus 9, you're going to get b to the negative 6. They don't want a negative exponent in your answer, so your answer is going to be 1 over b to the 6th power. That would be a proper final answer. Okay? All right, try one with numbers. Let's say 4 to the 5th over 4 to the 7th. See if you can solve that all the way. All right, so you should get 4 to the negative 2, which is 1 over 4 to the positive 2, which you can solve. 4 squared is 16. So that's 1/16. Okay. 3. Let's do 3y to the 8th over 9y to the 12th. How would I do this one? I guess I would reduce the 3/9 to a third. Y to the 8th over y to the 12th. See, now there's a few ways you could do this. Let me do one way. I'm seeing 8 y's up top, 12 y's on the bottom. Can you tell that that's going to leave you 4 y's on the bottom? So this could be your answer, 1 over 3y to the 4th. That's a very visual way to do that. Some people just like to do the rules. So they would get 1/3 y to the negative 4, right? Because 8 minus 12 is negative 4. Then you would have to know, okay, that means the y flips to the denominator and now has a positive 4. So that's 2 different ways to think about it. Visual way, you kind of picture where are the y's. There's 4 left on the bottom. Just using the laws way, you get the negative 4, but then you have to know that that flips it down to be y to the positive 4, but in the denominator. So you have a choice kind of how you want to solve this here. All right, so let's try this one. X y to the 5th over x to the 5th, y to the 3rd. All right, so I'm going to do the visual way first. I write the fraction bar. I picture 1x up top, 5 on the bottom. Once you cancel stuff out, there's going to be 4 left on the bottom. Right? The y's, there's 5 on top, 3 on the bottom. Once you cancel stuff out, there's going to be 2 up top. So that's one way to do it. If you just use the laws, 1 minus 5 is negative 4. 5 minus 3 is 2. Now you would have to keep the y squared up top, flip the x to the negative 4 to the bottom, and make it x to the positive 4. So either way, same answer. So either visually, I'm kind of picturing doing this, listing them out, crossing them off. That's what I'm doing when I say visually. Or just straight up use the law. You get the negative, you know you have to flip it. All right, we'll do a couple more. We might do more in class here, so let's do number 5 here. Let's say m to the 3rd, n to the 2nd, y to the 2nd over m to the 6th, n to the 8th, y. All right, visually, I've got 3 m's up top, 6 on the bottom. That leaves me 3 on the bottom. The n's, there's 8 on the bottom, 2 up top. That's going to leave me 6 on the bottom. Y's, there's 2 up top, 1 here. That's going to leave me 1 up top. If you do the laws, it would be m to the negative 3, n to the negative 6, y, and then you'd have to flip it to look like this, right? You would get the same answer. The m to the negative 3 would flip down, n to the negative 6 would flip down, y would stay up. All right? All right, one more. Let's say, I can't even read that, x, I can't read what that is, to the 4th, y to the 2nd, over x to the 5th, y to the 9th. Let's try that one. All right, visually, 4x is up top, 5 on the bottom. That's only going to leave me 1x on the bottom. 2 y's up top, 9 y's on the bottom. That leaves me 7 y's. What are we going to put up here? A 1, right? Because really when we're canceling things out, it's a 1. All right, if you use the laws, this would be 4 minus 5 is negative 1. 2 minus 9 is negative 7. And you'd have to do the same thing, flip them, same answer. All right? Okay. Good job, guys.